So I'm Robert Mosolgo. I work from home as a Ruby developer for a web startup called GitHub. I just started there. It seems fine. And I live in Charlottesville, Virginia. I know we have one other Charlottesville person. Any others? Anyone from Charlottesville? Sweet. So there's 3 of us. Actually, Peter and I are old neighbors, but we didn't know we were going to be here until now. At least I didn't. So I wanted to talk a little bit about GraphQL, which is something we use a lot at GitHub, and I've been working on a lot for the last 2 years. So imagine for a moment that you're a Ruby on Rails developer and you have an awesome website that people love using, and somebody says that you should build an API. Okay, why would you do that? What do people do with an API? Why should you go through the trouble? You already have a great website that people like to use. I think the reason that you build an API is for other developers to build on your platform, right? Maybe people want to keep the data from your system in sync with data from another system. Or maybe they want to build their own views with the data from your system. They're combining things a different way, keeping track of things on their own, something like that. So historically, or traditionally, I haven't been programming that long, so to me this is tradition. You have a kind of resource-based or REST API that looks like this. For every object in your system, there's a URL that identifies it, and the API is that people can go to that URL and get some information that has the representation of that object. Exactly what represents the object is up to the server, and whenever you get it, that's when you find out. Oh, by the way, my favorite hobby is playing Magic the Gathering, so all of my examples are Magic the Gathering related. So this is great. You have your API, other developers are interacting with your system, making great new things. Everything is awesome until you're like looking at your like New Relic performance stuff, and you're like, what is going on at midnight every day? Like our system almost crashes, or like why is our database like being so overworked? And it's because people are using your API. They're doing weird stuff, they're sending weird inputs, and as the server developer, it's a bad situation. So as the server developer, there is one bit of consolation, and at least the thing you can console yourself with is the job that your API clients have is also a really difficult one. So if you're an API client and you want to build a view like this, here's my deck of Magic cards. It says, here's Junk is the name of the deck. I guess non-Magic players probably don't know that right away. It says how many of each card is in the deck, and whether it's one of my favorite cards or not. And it says the set that the card was a part of, so when it was released. Now, if you're building that view, you can imagine there are a lot of objects that you need to build it. First, you need the deck in order to get the name and some of this quantity. And then for each, you need to know the user's favorites, so you can render those little hearts. And then for each card, you need to load the card's data, maybe the expansion that it was released in, and you just keep doing it. And it makes it hard. You have to, as the client, you have to fetch all of these resources and join them up yourself and keep track of what you have and what you don't have. So I'm thinking there must be a better way. Actually, I'm not thinking this. Facebook was thinking this like 4 years ago. And so they invented GraphQL, and they've been using it for 5 years or so. And they open sourced the idea a couple of years ago, and now it's implemented in all kinds of different languages. So let's take a look at what GraphQL is. This one looks pretty good. This is a screenshot of GraphQL, the GraphQL IDE. This is where you can write a GraphQL query, you can send it to the server, and then you can see the response. So I'm just going to describe GraphQL by giving an example. Here we go. So the first thing we're going to do is send a query. That means that we're fetching data from the server. It's like a read operation. So the deck that we were looking at before was ID number 2, and there's the name. So you can see, basically the structure looks kind of like JSON, right? You have the curly braces, and inside the curly braces are attributes, and you can request them by name. Let's see. So in this query, we're looking for a deck, and we have its ID number. and then we can ask for some properties of it, the name, and we can ask for the cards that it's composed of. And then for each of those cards, we get the card name. If you take a look at the response, you can see that the structure of the response matches the structure of the query. So for the query, the first thing we get is data. If there are errors, there's a top-level key called errors. And what we were looking for was a deck. And so here's the key, deck. We asked for a name. There's the name. And then for each card, we want the name of the card. Sure enough, that's what we got. So here's a simple GraphQL query just to fetch a little bit of data. I mentioned that query is the way that you perform a read operation. If you use the word mutation there, that's how you do like a create, update, or destroy. So now let's write a bigger query. Here's the query to render the view that I showed in the previous slide. First, we need some information about the deck. Since we need both the card and the quantity, we have a different application object involved here. I called it a slot, like your deck has all these slots where cards can be included. You might notice that autocomplete. That's because a GraphQL system is strongly typed and self-documenting. So every type in the system has some built-in documentation, and it's known ahead of time for each of its fields what kind of data comes from there. So you can have this really nice IDE experience that's correcting your spelling and showing you if you're starting to make a mistake. And here again, you can see that structure of the response matches the same structure we asked for in the query. That was a really fast introduction to GraphQL. You can fetch these objects, and you can make nested requests, right? For each object, you can reach through the relationships into other things. So now I want to show another feature of GraphQL. This is called query arguments. So we rendered the view for this deck, but what if we wanted to generalize a little bit? Right now we have the two hard-coded, and what we can do is replace the two with a variable. And then whenever we send the query, we can include the value for that variable like this. The resulting query is almost like a function, right? It has a name, it has some arguments, and then it's going to return a bunch of data. So you can imagine for each view, there's a corresponding query that's a little bit like the function to fetch data for the view. If you're ever writing a function, you might remember that it can come in handy to share logic between functions. You need some way to reuse code when you're writing a function. And so GraphQL has a unit of code reuse called a fragment. A fragment is a set of fields that's applied to a certain type, and you can, here we're going to extract a fragment and then reapply it to the query. So if you have views that need the same fields over and over again, this is a way that you can share that set of fields and keep everything in sync while you're developing. So the fragment is called slot info, and the type that it applies to is called slot. And you can see how it's applied with ... The structure of the output is just the same. We've just reorganized things a little bit. Okay, if you ever read anything about GraphQL before, this was probably the title of the thing that you read. And I'm going to do it again anyways. I want to compare the traditional resource-based API with GraphQL. So in a resource-based API, every object has its own URL. You go get it, or maybe you update it, and then the server responds with something. If you're lucky, it's documented. If you're really lucky, the documentation is up to date. And if you're really, really lucky, it's documented and the documentation is up to date and the server isn't making any mistakes. As a Rails developer, maybe you know that IDs can be integers sometimes and strings at other times. And you just have to hope you get the right thing. The difference with GraphQL is that there's only one endpoint. So we were looking before at that IDE, and every time we clicked the send button, it was going to the same URL. The other thing is the structure of the response is described and defined by the client, and the objects are strongly typed and they don't change. So as long as your query runs, you can keep sending it and keep getting the same response. The other thing that's different is the way that you access related resources. In a REST API, each resource has its own endpoint, so if you want something different, you make another request. In GraphQL, the way that you can access related resources is through properties or through fields that objects can reference one another. As a client developer, this is a little easier because you only make one HTTP request. You can get everything you need in one go. Now, it wouldn't be fair to compare the two without showing some downsides of GraphQL, especially if you're imagining your own system. You can imagine that this would be abused. Here's a really mean GraphQL query where, for me, we're going to get the first 10,000 decks, and for each deck, the first 10,000 cards. And then for each card, who is the artist who did the art and what was their name? That's going to be a lot of data, and it's probably going to crash your server or occupy your database, and people won't be able to get in. So by making this really flexible system, you have to cope with the flexibility on the server. And that's what I'm going to talk about in a few slides from now. This slide is kind of a joke, but it's not really a joke. Sometimes people hear about this really flexible system, and they say, if you're going to do that, why don't you just give your clients some credentials to your MySQL server and let them get the data themselves? And there are a few, first of all, it's a good point. When you're giving someone flexibility, it's risky. But there are a few important differences. With GraphQL, the logic for fetching this data is all implemented in Ruby. So whatever models or authorization or business logic that you already have in your app, you call the same methods inside your GraphQL system. The other thing about GraphQL is that it's backend agnostic. That is to say, if you're using Rails, probably a lot of your data is in some SQL database, but probably some data is other places, right? Maybe it's Redis, or maybe you integrate with an external API inside your Rails app. And so with GraphQL, you can, since it's all Ruby code, you have all of these different storages underneath, GraphQL kind of as a layer on top. The clients only interact with GraphQL, and under the hood, you can use any kind of storage. So you can imagine if you gave people access to your database, you couldn't really change the structure without breaking the queries that people are trying to run. That's not true for GraphQL because you can, even if you change the storage, you can maintain the same system. So we talked about GraphQL is implemented in Ruby. I should give a disclaimer. There's a GraphQL Ruby gem, and I wrote it, so I'm biased. Also, I know its flaws, so I'm going to try not to dwell on those, at least right now. I mentioned before that a GraphQL system has all of these types, right? It's an object with some fields, and let's see how to define that in Ruby. It basically looks like this. For the different objects in your application, you can define an object type that wraps it. You can imagine there's an active record model that's also named card. And here we have a GraphQL type named card. Here's the description. So this is part of the self-documenting nature of GraphQL. For that object, it has some fields. This is like the kind of data that you can fetch for a given card. And each one of those has a type. These fields, like ID and name, you can imagine that they map to active records methods, right? And so by default, a field just calls a method with the same name. Also, I mentioned that the objects can reference one another. So we have a card, and the way Magic Cards works is like every 3 months they print another 200 cards, and then I go buy them, and I just keep doing it year after year. And so each card belongs to an expansion. That's the set of cards that it's printed with. And here you can see how that relationship works. For the card, you call its expansion method, and the thing that comes back is an expansion. Sometimes you need a little trickier logic than that, right? So here's an example with a custom resolve function. So the little stabby, that's a Ruby proc or lambda. I'm not actually sure which one. It's a function. And you can see the custom logic here. Here's that card. And in order to get the image path, we actually have to reach through one of its relationships and then get the image path. We can talk about magic cards later. But this is the idea that the system, GraphQL, has a little bit of isolation from your application. You can have custom logic to satisfy the needs. And if you're changing your storage, this is how you can maintain it as time goes along. Oh, I work at GitHub. I just wanted to say a little bit about how we use GraphQL there. So I mentioned before that you would have an API so that people can integrate with your system. And that's a big part of how people work with GitHub, whether it's your CI server or project management or code climate, these different things, deploying to Heroku. There are all these people who integrate with GitHub really closely, and we're trying to make it easier for them to do so. So that's why they chose GraphQL. It was before I worked there. And then the other thing we're doing that's super interesting is that a lot of our Ruby on Rails views, in fact, in the controller, run a GraphQL query, and that's the data for the view. Okay, that's crazy. Why would you ever do that? The reason is because it centralizes data access. So rather than making database calls everywhere in the view, you can run everything through GraphQL, and then you can keep an eye on what's slow and what you need to optimize, what things get used the most or not the most. So it's been a really cool project to join. I mentioned before that if you give people this kind of flexibility, there's some security trade-offs that you have to make. So I wanted to talk a little bit about how we solve those at GitHub. The first part about serving an API request is authentication. That means somebody comes to your system, probably with a password or a OAuth token or whatever, and says, hi, I'm user so-and-so, and you have to figure out, are they actually the user that they say they are? The good news here is that for GraphQL, it basically works the same way as any other Ruby on Rails controller. So the first thing you do is, I called it authorize. Maybe I should have called it authenticate. The first thing you do is check that user, right? Maybe you look them up by the token that they have and make sure these things match. And then if they match, you keep running the controller action. Here's how you run a GraphQL query. You take the query string that they gave you, and you execute it. The result is some JSON. There's also something here called context that I thought I was going to have to introduce, but thank you, Sam, for introducing it. This is what you do with the user after you've logged them in. You make something called GraphQL context, and then you pass it through the query. And just the way he was describing, this is an object that passes through the entire query so that you can keep track of what's going on, or you can check the permissions of the user. And that's the next part. This is authorization. So we have a logged in user, and this user is asking to access some different data. And now we have to say, is this user allowed to access the thing that they want? And again, there's some familiar techniques that apply here. The first one is, whenever you're fetching data, make sure that your fetch is scoped, right? Like if I'm searching my own cards, here I've fetched the current user out of the context, and now when I search the cards, it's current user.cards. Those are my cards. And then we search it. So instead of searching all the cards in the entire system, we scoped it to begin with. Another part of authorization that's unique to GraphQL is this idea that whenever you execute a field, you get some result. And you can make a last-second check. Can this user really see the object that we fetched from the database? And so it works like this. First, you call the field as usual. That was the thing that I just showed you, where you fetch some data from the database. But then you insert this extra check. Are they really authorized to see this? And if they aren't, we need to stop right now. Raise an error, log something to your system, maybe send someone an email, however it works. And then you can come back and look at, why was this user able to see something that they shouldn't have seen? So this is something that we use as we're developing the system to keep an eye on, are we loading things correctly, and are we returning things that we ought to return? And there's one other really interesting bit of work here. This is HackerOne's GitHub account, or maybe HackerOne was taken. And they just recently released a new gem that they use with GraphQL Ruby to do this authorization. It's a really cool approach. If you're interested, you can find more, but the gist of it is like this. You have a certain object, like maybe it's a card or a deck, and you have the current user, and you wrap them together in one kind of proxy object that includes both the, the deck and the user. And whenever you send a method to that object, it does this authorization check for you. So it acts just like the deck, but it's always making this authorization check. It's kind of an authorized proxy. Very cool approach. Another issue that we have at GitHub, and anybody has if you had a GraphQL API, is how do you make sure that people don't slam your system? And with a resource-based API, it's a pretty straightforward thing to do. For every request, you increment a counter, and then every 1 minute, just reset the counter. And if the counter goes over 1,000 or 10,000 or 100,000 or whatever, just stop serving their requests. Say, come back in 30 seconds, or come back in a minute, or come back in an hour. How can you do that with GraphQL? We have this idea called nodes in GraphQL. Every object that comes back in the response is one node. And looking at a query ahead of time, you can actually guess how many nodes are going to be there. So let's do it for this query. First is the top level query keyword, nothing there. Next, we fetch the deck with ID 100. There's one node. We get its name. That's not an object, it's just a string. And then we ask for the cards in that deck. But we're only asking for the first 10. So the most that could be returned is 10 cards. For each card, we're getting name and colors. Those are just strings. And then we're asking for the artist who did the art for that card and their name. So here's one extra object for each of the cards. So we end up with the one artist multiplied by 10. Altogether, it's 21 nodes. And this is what we use for rate limiting at GitHub. For each query that comes in, we count how many things it might return, and we increment the counter based on that. So it's a similar approach with a new spin. The Ruby gem itself has a little bit of support for that, and that's the URL in case you're interested. It's called complexity, this measurement of how much the query is going to cost. There are a few things I didn't have time for in this talk, but I'm going to put them on this slide so that if you talk to me later, we can have something to talk about. One of them is, when you're executing this complicated query, how do you make sure that the database access is efficient? Shopify has a nice library for that, but I didn't include a link. You can search for it. The other one is, there are more ways that you can analyze this incoming query. So at GitHub, when someone sends a query, the first thing we do is analyze it and compare it to the OAuth scopes that they have. And if they don't have the right scopes to access these kind of objects, we send it back and say, you can't access such and such because you don't have scope such and such. Another way that we defend ourselves is with a timeout. Basically, this is a last-ditch effort. If somehow we've missed something, or we're waiting for an external service that's taken too long, we can just quit in the middle and stop. The last thing is something called instrumentation. This is a way, when you're resolving these fields, to programmatically wrap the resolution with logic or checks, kind of like the authorization that I showed earlier. If you're interested in GraphQL and want to talk more about those or anything else, I would love to talk to you about it afterwards. Like I said, I work from home, so I don't get to talk to people that much. Maybe it shows. I'm all done, but I put some URLs here if you're interested to learn more. Those are some places you can look. I think I'm all done. I also brought some stickers that have this little logo, so if you come talk to me, I'll give you a sticker. You don't even have to talk to me, you can just ask for a sticker. Okay, thank you so much. I'm done.